Hey guys, welcome to the fifth day of this 30 days Leetcode challenge for April 2020. So today we are solving the 50 problem. Uh, the problem is best time to buy and sell stock. So let's see what the problem statement says. Say you have an array for which ith element is the price of a given stock on day I. So we are given an array of integers, and those integers represents the price of given stock and at index I. Now we have to design an algorithm to find the maximum profit. Okay, and we are told that you may complete as many transactions as you like, that is buy one share and sell one share of stock multiple times. So we are told that multiple transactions are allowed. However, we are allowed to buy only one share and sell only one share. At the same time, we are told that you may not engage in multiple transactions at the same time. That is, you must sell the stock before you buy again. There is no condition for short selling mentioned, so you cannot first sell the share and then buy it again. If you want to know what short selling is, you can search it out on the Wikipedia. You'll probably get a lot of information. But for our consideration, in for our case, short selling is not allowed. So we can only buy at a lower price and sell it when we are getting a profit. So let's try to understand it with an example. So in this we are given different prices of the array, prices of the stock, and what we observe is if we buy at 7, uh, it it after 7 there is a price of 1, so it makes it's a good idea to buy at 1 than buying at 7. Now if you check the array, that after buying at 1, we have a good opportunity to sell at 5. uh, After this, there is an opportunity to sell at 6 as well, but it's a good idea if we buy at 1 and sell at 5, and then again buy the stock at 3 and then sell it at 6. So in this case, what we'll do is there are two places where we can earn profit. We can earn profit of 4 rupees here, and we can earn a profit of $3 here, so making it a total of 7. So uh, yeah, for our second example, we are given an array that uh, has prices increasing every day. So what we can do is we can buy it on the first day itself and sell it on the last day, which helps us earn a profit of 4. uh, Now in the third example, we are given all the array. The array contains all the integers in decreasing order. So there is no opportunity for us to buy at a lower price and sell at a higher price. So our profit in that case will be a value of 0. So before I start discussing the algorithm, I'd like to explain it with some drawings. So let's say this is our coordinate system. The x-axis represents the days, and y-axis represents the time. So what I'm going to do is I need 3 pointers. One will one will point to the buy value. The second one will point to the sell value, and the one will be our runner, which will be iterating through the array. So what I'll do is let's say this is the point where we start. So what I'll do is I'll initialize my buy and sell value to this to whatever index this is pointing to, and now there is a possibility that the price can either increase, it can go up, or it can go down. So let's say initially if the price goes down, then it makes sense to buy at this value compared to buying at this value. So what I'll do is I'll update both my pointers, the buy and the sell pointers, to point to the new value. Okay, and let's say after this, let's say if the price increases, then it makes sense that this is a good point for buying, since after buying the prices started increasing. So it we can say that we can be assured that this is a good point to buy, but we cannot be sure that this is a that we have arrived at a point that is good for selling. because there is a possibility that the prices can further go up, and if we sell at this point, then the new value won't be available to us. So if the price further goes up, what I'll do is I'll update my selling pointer to point to this new value. And let's say after that, if the price goes down, then we can be assured that this is a good point to sell. So I can book my profit and update my pointers, the buy and sell pointer, to point to this new value. So after booking the profit, it does not make sense to keep pointers pointing at this values. So what I'll do is, after booking the profit, I'll update it to whatever is the new index uh, that contains the value. Now there is again a possibility that the prices can further fall. So if the price falls, then we just book a profit of 0 and update uh, our min index, our buy value index, and the sell value index to point to the new value. Okay, so this is what our code will look like. And let's say if the price increases after this, then then we can be sure that this will be a good point to buy. And um, when we run out of all the elements, then we can be sure that the difference between these two will be our profit. So let's try to code this. So what I'll do is, I'll keep a pointer as a buy value index. This will store the index where we can buy, and there is a sell value index which will store the index where it's a good point to sell. And I'll say this is my runner. So while my runner is less than the prices dot length, while so I'm iterating through each of the price. And what I'll check is, if so let's consider this point. If my runner is pointing to a price that is less than the price that of max index, then what I should do is book the profit. Okay, so that is what I'm going to do. If the prices that our runner is pointing to, if that is less than the prices of whatever the sell value index is pointing to, in that case I should have a variable which stores the profit, and I'll initialize it to 0. So the prices, uh, the profit, sorry, the profit in this case will be the difference between whatever the sell value index is pointing to, and the buy value index is pointing to. Now both the buy and sell value might be pointing to the same index, as if the prices are continuously falling. So like as we saw in this case, if the prices are falling, then what you can think of that as booking a profit of 0 and updating our pointer. So we have to update our pointers as well. The sell value index will point to whatever our runner is pointing to, and the buy value index will also point to whatever our runner is pointing to. Now, what will be the other case? So this is if the price is decreasing, or ideally I should also do the same thing if the price is uh, becomes less than or equal to. So let's say if there is a sideways movement after this, then we can say that this is a good price to book the profit. Okay. So what should be in our else part? So we have taken care of booking the profit whenever we find that the new value that our eye is pointing to is less than whatever the max value is pointing to. But what happens if our if it is in this path? So what we want to do is, whenever if we find that the price is increasing, what we have been doing is updating our sell value pointer. So what we'll do is, our sell value pointer will point to whatever our runner is pointing to whenever the prices are increasing. Now what we have not done is handle the boundary condition. So when we when we run out of all the indexes, what we should be doing is adding this. We have not taken this profit into consideration. So once we are out of the loop, our profit should also take into consideration whatever the sell value and buy value at the end are pointing to. Now they may be pointing to the same value if we exit, if the last index that we are given, uh, if the last index that we are given is of decrease in the price. So in that case, we'll end up booking a profit of 0. So this is what it is, and we should return the profit. Now, since we are accessing the sell value and buy value index out of the loop, so we have to ensure that there is some element present. Otherwise, we'll get an index out of bound exception in this case. So I'll add a boundary condition that if the prices array given to me is null, or there is no element uh, in the array, then I'll return a profit of 0. So let's submit this code and see if this works. So, oh, time limit exited. Oh, I forgot to increment our runner pointer. So let's run it again. So in my code, I forgot to increment my pointer. I did all the calculation, but yeah. So, so it does work. Let's submit our solution. So it has been accepted. Let's see if we are how good our solution was. Okay, so we are better than 91% of all the Java submissions. So what can be wrong? We are iterating through the array only once, and there is a constant amount of extra memory that is allocated. So probably there is something simpler that we can do. So to get to 100%. So let's see if there is something we can do about this. So if you look at the graph, ideally what we are doing is adding up wherever there is a price increase, and wherever there is a price decrease, we are not even considering them. So what I can do is in a single pass, whenever the price is increasing, I'll say book that profit. So I see that there is a price decrease here, but I see that there is a price increase. So I'll book this as a profit. Then I again see the price as an increase. So I'll again book the profit. Now, since there is a price decrease, I won't consider that. There is a price decrease here as well, but I see that there is a price increase in this case. So I can add this value as well. So we can do this in a single pass. So let's see if that gets us to 100% better solution. So ideally what we'll need is I'll need a runner, and I'll need a profit, and what I can do is uh, while while I is less than while I'm iterating through all the elements, what I want to do is check if the element at index I, if uh, if that is less than the element at index I plus 1. So I'll say that book a profit by subtracting these values. So whatever is the price at I plus 1, and the difference between the price at I plus 1 and I will be booked. Now if since we are using I plus 1, so I cannot go up to length, so I should only go up to length minus 1. I think this is the simplest solution. I don't think this case is required because there is nothing we are accessing outside. However, if the price is null, uh, in that case we'll still need to return a value of 0. So we can remove this, but even the loop will take care of it. So let's keep it there for the time being, and let's run the code. Sorry, I forgot to increment I again. Uh, This is the case with using the while loop. You have to explicitly remember incrementing I. It's a good idea if you use the for loop. Yeah, so this is also giving us a correct solution. Let's submit it and check if we are getting into the top 100%. Uh, no, we are still at 91.19%. Uh, okay, I do not know how to improve this further. Probably, I don't know. So I'll close this at this point, but I don't think there is any further optimization that can be done in this case. So yeah, thanks for watching, and if you find anything, any better solution, please do let me know in the comments. Yeah, thank you.